Hi, welcome to Lesson 6 of Week 2 of Julia Programming for Nervous Beginners, in which we address the scope of functions. So this is our first lesson about scope, and the idea is just to introduce the concept of scope as it applies in Julia programs. So, after this lesson, you'll be able to say what the scope is of a block of code. You'll be able to say what it means for a block of code to have local scope. You'll be able to explain the difference between local scope and global scope. You'll be able to explain how a function in Julia treats variables from the global scope. You'll be able to use the keyword global to make global variables accessible to writing inside a function. And you'll be able to explain why, even though they're global, the values inside an array can be modified inside a function. So, what is scope in the sense of programming? The term scope refers to the variables that can be accessed inside a particular block of code. So what is a block of code? Well, it's any portion of a program that doesn't leave any lines between the first and the last line out. So the program as a whole is a code block. The variables that are accessible inside the program as a whole are called the global variables. Some code blocks introduce a local scope. Variables that are local to that scope cannot be accessed by code outside the code block that introduces the local scope. So you've already seen one code block that does that, which is a comprehension. So here's a comprehension, this line here. So let's go over to the REPL and say that the variable xyz is the string abcd, and that we now create a comprehension which is lockvar repeated 4 times for lockvar in x, y, z. And now we see that what has happened is that we have, for every one of these characters, A, B, C, D, we've repeated them 4 times, and we get an array with 4 elements, which is exactly what we expect looking at this. But if we ask for what the value of lockvar is now, so lockvar has taken the value A, the first one, and it's made it 4 times there, and then it's taken the value B, and it's made it 4 times there. But lockvar itself is undefined. So lockvar is visible only inside the comprehension. And that's what we mean by it being a local variable. So a variable, of course, can be read only, or it can be read and write. So on this course, all of the code blocks that do not use local scope are part of one global scope. We only use one global scope at a time. So which keywords introduce new scope? There are not that many of them, but in this lesson we will focus only on the keyword function, and it creates a local scope. So all of the variables that are created inside the function body are local to that scope, and for all practical purposes they are invisible to any code outside the function body, like the values for lockvar that are created. They refer to lockvar, and if we're not inside the comprehension, the lockvar that we use inside the comprehension is invisible to any other blocks of code. Now, what happens if we reuse a name to make 2 different variables, the one local and the one global? Then we have a conflict. So in order to resolve that conflict, computer languages make different choices. In Julia version 1, the global variables are accessible for reading inside a function, but not for writing. And if we want to make them accessible, then we can create we can use the word global to annotate the variable so that it actually does become valuable. So here, if we have these 2 functions, we'll go back to the use of the word global to make a global variable accessible for writing. But before we do that, let's just look at what the scoping rules might do in this case. So we have the function eg1 of x, which is x plus y. So y is not one of the arguments for eg1, but it is one of the arguments for eg2. Okay, so we have eg1 of x equals x plus y, and that creates a function, and we can have eg2 of x and y. So now it's got two arguments, and we create that. And now we can, let's just go back to see what example we want. We have x, y is 2, 3. Okay, so if we say that x, y by multiple assignment is 2, 3, then we can ask for what is eg1 of x. So x is 2, y is 3, and it comes up as 5. eg1 of x, eg2 of xy will of course also be 5. But now I can change the value, say, of x. So I can say x is 4, and then I can repeat that. And eg1 is then 7 because x is now 4 and y is still 3, and eg2 is also 7. If I have y is equal to 3, and I now have eg1 of 6, then I get 9. But if I have eg2 of 6, eg2 of 6 and 7, then it's no longer equal. So what we see is that the y that gets used in eg2, this x plus y, is this 7. Whereas the y that gets used in eg1 is this y. This y equals 3, at this top level here. It's not inside the function, it's in the outside of the function. This is the global y, the y in the global scope. By putting eg2xy, we have created y in the local scope. So this x and y is local, and they can be modified. So let us look at a function eg1 and eg2, and again now we make function bodies, and we create eg1, z is now x plus y, we return z, but we try to modify y by making y equal to 11. Okay, so we have function eg1 of x, and that means that z equals x plus y, and y equals 11, and we return z, and we end the function. I like to do that. And we can have eg2, which is almost identical, except that eg2 has x and y. And now we can, let's just see what x and y are. There are 4 and 3, so if we ask for eg1 of 6, y is not defined. Function eg1 and eg2 defined inside a function body. So now this starts with function and end, and function and end, and we have an attempt to change the value of y inside each of them. So in the repo, I've already entered those functions. There they are. So let's try eg1 of 6, for instance. And that won't work. Let's try eg2 of 6 and 7. And that works. But let's see what the value of y is. we see that the value of y has not been changed. So function 1, when it got to y equals 11, it said y equals 11 is not defined. Function 2, when it got to y equals 11, it assigned 11 to the local variable, did nothing with it, and returned the value z. So if we change y equals 11 with global y equals 1, let's see what happens. So we go back to function 1 and we type global y equals 1. And we enter that. And now we ask for EG1 and that gives us 9 because y is 3, right? That was the value of y. But let's see what the value of y is. In fact, the value of y is 1. So here we have successfully changed the value of y to the value of 1 because what happened was that first function EG1 took the value of x that it received, which was 6, and then it computed the value of z and x and the value of y, and the only variable that is accessible is the global variable, and so it computes 9, and that is the z that is returned. It also, at the same time, computed the assignment y equals 1 for the global variable y. And then that is, of course, 1, as we've seen many times before. And we can do that, of course, in, let's see what happens if we try and do it in EG2. So in EG2, let's make that global y equals 11. And now it says no. Here y is a local variable and we cannot make it global. There is a clash between global and local. Over here there is no local variable y in EG1, and so there is no clash. We can just say, hey, wait a minute, when we talk about y, we want actually to be able to write to it and not merely to use its value. When we go here, we've created a local variable y, and when we want to say that this must also be a global variable, it says, no, you can't do that. It's a local variable. You can't make a local variable global. The only thing you can do with a global keyword is to make a variable that is global writable inside. Okay. So we see that specifying y as global inside the function body works only if it hasn't been specified as local in the argument list. And by the way, we don't have to use a global with assignment as we did here. We can just have the line global y anywhere in the function body, and then we can have y equals 11 sometime later. So now there is a special case of arrays. So let's look at these functions. Mod AA doesn't take any argument, and it tries to assign to AA the value 7. Mod BB doesn't take any arguments, and then it says BB is an array. The second element in the array gets the value 7. And let us look at when AA is 1, 2, 3 is the number 123, and BB is the array with two elements 1, 2, and we see what happens with them. Okay, so mod AA is mod AA, oh, it's a function. I want the function mod AA, and it simply tries to set AA equal to 7, and then we end the function, and we have mod BB, which tries to make the second element of B equal to 7. And now we say AA BB is equal to some values. Let's take some different ones, 3, 6, 9, and the array with just 2 elements, we will make that -4, -7, no, -777. Okay, and now we ask for what is mod AA mod BB. They don't need any arguments. We're allowed to make functions that don't call any arguments and just try and do things. And we see that the answer is 7, 7. Let's ask what AA is. Sorry. I hit cap locks by mistake. AA is 369, but BB is not -4, -77. BB is just 7. Let's see what BB is. BB is -4 and 7. So the two results we got is that mod AA is 7, and then this 7 is this element here, the modification of BB. So as expected, mod AA cannot modify, although we say mod AA is 7, and we inside the function, when the function has run, it turns out that AA is still 369. That 7 we see is a bit confusing, and I'm not going to explain it now. And on the other hand, mod BB, BB starts -4, -777, but BB ends -4 and +7, because BB equals at 2 is made 7 inside it. So this is a puzzle. Why are we allowed to change a vector, although the vector is not declared global? BB is not declared global, but we can change its elements. This is actually not peculiar to functions, it's general behavior. When you create an array, Julia tries not to have to allocate new memory. So let's look at the code on the left here. AA is 2, BB is equal to AA, and BB is 3, and then we println the value of AA, we tab, and the value of BB. Remember that the dollar is a string interpolation. So let's do that. AA equals 2, BB equals AA, BB equals 3, and we println a string in which we have the value of AA, and we tab, and then we have the value of BB. And we see that AA is 2 and BB is 3. So AA took the value 2, then BB was AA and it was 2, then BB was given 3 and it became 3. But AA didn't change. However, if we make it like this, so we make AA the array 1, 2. So AA is now made the array 1, 2, and I don't want to see it. And then everything else is the same. We have BB is equal to AA, and we have BB at 2 is equal to 3. And now I ask to see that. And we see that AA, as expected, BB at 2 is 3, but AA has also changed. So, this is behavior that might be a bit unexpected for some of you used to other languages. But the important point is that when we have BB equals AA, the BB binds to the same bit of memory as the name A. When BB is equal to 3 is executed, the name BB simply binds to a new bit of memory, and then we end up. But on the right, when BB equals 2 equals 3 is created, then it doesn't bind to new memory. What happens is that we have the BB at 2. There's a bit of memory which contains 2 values, an array with 2 values. This name, BB here, binds to the same bit of memory as what AA was bound to. So there's only one piece of actual memory, but 2 different bindings. AA is bound to the memory, BB is bound to the memory. When we do this, BB at 2 is 3, we simply change the little bit of memory. We don't actually change the binding of BB to the memory, we don't change the binding of AA to the memory, but we change the memory itself. And that's why when we print it out, AA and BB are still equal. So in this code here, AA and BB end up not equal. And in this code over here, AA and BB end up equal because here it's a block of memory. AA refers to the block of memory. BB refers to the same block of memory. BB at 2 changes a little bit inside the block of memory. And so that same block of memory that AA referred to has now been changed, and so AA and BB still refer to the same block of memory, and so they're still equal. But over here, when you say BB equals 3, then you create a slightly different piece of memory which contains the value 3, and in this code there are 2 different pieces of memory when it's all said and done, and here it still remains the same piece of memory, although it's bigger because this one is an array and this one is not. So why has Julia chosen that? And the reason is because the designers of Julia favor performance. So they wish to avoid copying arrays whenever they can. And so that means that when BB 2 equals 3, no new memory is created. In a small array like this, of course, it won't make much difference, but arrays can be enormously large, billions of numbers. And so then you don't want to have to copy out the whole array just because one element has changed. And so what happens is that the actual physical memory is changed, but the actual name that is bound to that memory is not changed. So that means when you run a function, the same thing happens. The binding of BB to the memory is not changed, but the content of the memory itself is changed. So let's have a review and a summary. Any part of code can be a block. All that is needed is that the entire code from beginning to end is included in the block. That's what we mean by a block of code. The scope of a block of code is all the variables that are visible inside that code. Variables can be visible for reading only or for reading and writing. A block with local scope means that variables created in that block are not visible outside the block. A comprehension creates a local scope. A function creates a local scope. The local scope starts immediately after the function keyword and ends with the end keyword. It means that the variable names that you give to the function is actually local to the function. Global variables are visible inside the local scope of a function, but for reading only. They cannot be modified. Any variable that are mentioned in the input to a function call are in the local scope of that function. The keyword global can be applied to the variable name inside the function body, and for those variable names to which it is applied, it makes a global variable of that name available to writing inside the function body. Values, if you have an array in the global scope, then you can actually still modify the value of that array inside the local scope of a function, but you have to modify the values inside the array. You're not modifying the array itself. And finally, when an array valued variable is assigned to a second name, both names always bind to the same value, and so when you change the elements in that array, it changes both variables. And that's the end of our first discussion of scope, and also the end of week 2.